Welcome, beginner game developers. Today, we'll embark on an exciting journey to build a fundamental game mechanic, a countdown timer system in Unity 3D. This tutorial is designed to be comprehensive, guiding you through every step of the process from initial setup to advanced enhancements. This tutorial will guide you step by step through creating a new C# script, writing the timer logic in Visual Studio, and integrating it seamlessly into your Unity project. We'll cover all the essential details to ensure you have a solid understanding of how to implement this crucial game feature. Our goal is to create a robust, frame rate independent timer that displays minutes and seconds and can trigger events when it reaches zero. This means your timer will function consistently across different hardware and game speeds, providing a reliable experience for players. Let's begin by setting up our project in Unity. First, navigate to your project window, which is typically located at the bottom of your Unity editor, and create a new C# script. This script will house all the logic for our countdown timer. Name this script Countdown Timer to clearly indicate its function. This descriptive name will help you easily identify its purpose later on, especially as your project grows and you add more scripts. Consistency in naming conventions is a good practice. Next, we need a game object to manage our timer's logic. Create an empty game object in your scene by right-clicking in the hierarchy window, then selecting Create Empty. This game object will serve as a container for our script and its associated components. Rename this new game object to something like Timer Manager for clarity. Then, drag and drop your countdown timer script from the project window onto this Timer Manager game object in the inspector. This action attaches the script as a component to the game object, allowing it to execute its code within the game. Now, let's create the visual element for our timer. Go to Game Object in the Unity menu bar, then UI, and select Text Mesh Pro. This will create a new UI text element in your scene, which we will use to display the countdown. Text Mesh Pro is recommended for its superior text rendering capabilities compared to the default UI text. This UI element will display the countdown value on your screen, offering crisp and clear text that looks great at any resolution. With our Unity setup complete, it's time to dive into the code. Double-click the Countdown Timer script in your project window to open it in Visual Studio. This is where we will write the C# code that brings our timer to life. The first step in Visual Studio is to include the necessary libraries. We'll need Unity Engine.ui if you are using the legacy UI text, and TM Pro to interact with our Text Mesh Pro UI element. These using statements allow us to access the classes and functions provided by these namespaces. Next, we declare our variables. We need a public float timeleft to store the remaining time, allowing us to adjust it directly from the Unity inspector. Initializing it to a value like 60.0f provides a starting point for our countdown. We also need a public TMP_text timer text to reference our UI Text Mesh Pro element. This variable will be assigned in the Unity inspector by dragging our Text Mesh Pro object onto it, creating a link between our script and the visual display. Finally, a private Boolean timer active will control whether our countdown is currently running. Initialize it to true so that the timer starts counting down as soon as the game begins. This flag is crucial for pausing or stopping the timer. Now, let's implement the core timer logic within the update method. This method runs once per frame, making it the ideal place to continuously update our timer's state and display. We'll place our countdown calculations here. First, we check if timer active is true. If so, we subtract time.deltaTime from timeleft. This conditional check ensures that our timer only counts down when it's supposed to be active, allowing for pausing or stopping. Time.deltaTime is crucial as it provides the time passed since the last frame, ensuring our timer is frame rate independent. This means the timer will count down at the same real-world speed, regardless of how fast or slow your game is running, preventing inconsistencies. Next, we add logic to handle when time left drops below zero. We set time left to 0 to prevent negative values and timer active to false to stop the countdown. This ensures the timer doesn't continue counting into negative numbers and properly concludes. Inside this block, we can also update our timer text to display a time's up message, signaling the end of the timer. This provides clear feedback to the player that the countdown has completed and any associated events should now occur. For all other cases, Where the timer is still running and time left is greater than 0, we update the timer text to show the current time left value. Using toString formats the float to 2 decimal places, providing a more precise display. Now, let's refine the display to show minutes and seconds, which is much more user-friendly and intuitive than a raw float value. Players are accustomed to seeing time in this format, making it easier to understand at a glance. We calculate minutes by dividing time left by 60 and using math.floor2int to get a whole number. This effectively converts the total seconds into full minutes, discarding any fractional parts. Seconds are calculated using the modulo operator. Time left %60, also floored to an integer. This gives us the remaining seconds after the minutes have been accounted for, ensuring the seconds display correctly within a 0 to 59 range. Finally, we use string format to display the time in a MMSS format, ensuring leading zeros for single-digit numbers. For example, instead of 1:5, it will display 105, which is a standard and professional presentation for timers. With the code written, save your script in Visual Studio and return to Unity. Select your Timer Manager game object in the hierarchy. This will allow us to configure the script's public variables in the inspector. In the inspector, drag your TextMeshPro UI element from the hierarchy into the timer text field of your countdown timer script component. This establishes the crucial connection between your script and the visual text display in your game. Adjust the time left value in the inspector to set your desired countdown duration, for example, 60 seconds. This public variable allows you to easily change the starting time of your countdown without needing to modify the code directly. Now, hit play in the Unity editor. You should see your timer counting down in the UI element, displaying minutes and seconds. Observe how it accurately counts down and eventually displays times up when it reaches 0, demonstrating our logic in action. Let's explore some enhancements and best practices to make your timer even more robust and versatile. These tips will help you build more sophisticated timer systems for various gameplay scenarios. To trigger an action only once when the timer reaches 0, use a Boolean flag, for example, timer in. This prevents the action from being called repeatedly every frame, which can lead to unintended behavior or performance issues. Set timer ended to true after the action is performed. Always ensure that time left doesn't become negative. Setting it to 0 when it reaches 0 avoids display issues and unexpected behavior, ensuring your timer always shows a non-negative value and stops precisely at 0. For games, you might want to start delay before the main timer begins. This is common in racing games or challenges, giving players a moment to prepare. Use a separate float variable for this delay, like start delay. Display this delay time on the screen, perhaps with a 3, 2, 1, go sequence, and once it reaches 0, activate your main countdown timer. This creates a more engaging and professional user experience. Unity's time.timescale property allows you to control the speed at which time passes in your game. Setting it to 0 pauses everything, including your timer, which is useful for pause menus or cinematic sequences. Setting it to a value like 0.5 will slow down time. If your UI text isn't updating, verify that the update method is being called and that the text component is correctly referenced in the script's inspector. A common mistake is forgetting to drag the TextMeshPro object into the timer text slot. Also, ensure the text component itself is large enough and positioned correctly to display the text without clipping. Check its rect transform properties in the inspector to make sure its width and height are sufficient and its position is visible on screen. While time.delta time is excellent for continuous updates, for precise timing, especially for sequences or events that need to happen after a specific duration, coroutines with wait for seconds can be an alternative. Coroutines allow you to pause execution for a set amount of time. To persist timer values between game sessions, such as for daily rewards or cooldowns, you can use player prefs to save and load data. This allows your timer to continue its countdown even when the player closes and reopens the game. Finally, a great visual enhancement is to change the timer text color based on the remaining time, like turning it red when time is low. This provides an immediate visual cue to the player about the urgency of the situation. This simple visual cue can effectively communicate urgency to the player, prompting them to act quickly as the time runs out. It adds a layer of polish and responsiveness to your game's UI. By following these steps and incorporating these enhancements, you've built a robust and user-friendly countdown timer system in Unity 3D. This system is flexible enough to be adapted for various game mechanics and scenarios. This comprehensive guide covers everything from basic setup to advanced features, ensuring a smooth learning experience for beginner game developers. You now have a foundational understanding of how to implement and customize timers in Unity. Keep experimenting and building amazing games. The skills you've learned today are transferable to many other aspects of game development. Thank you for watching, and happy developing!